Thanks everyone for coming to this session about La La Land of DevOps integration. There's actually an alternative title would be continuous delivery, tooling, patterns, anti-patterns. Just I thought La La Land was more fun. So I'm going to talk about what are the two camps that we see often when we're talking about integrating DevOps tools and tool chains, and then some practices and patterns that I found useful with clients to improve their continuous delivery practices. So I'm Manuel Pais. I'm a DevOps and continuous delivery independent consultant. I'm also co-curator of the DevOps Topologies website with Matthew Skelton. If you don't know it, I recommend having a look. I think it can give you some ideas about organizing teams for DevOps. So getting started about these two camps of DevOps integration. So actually, the reason why I use the La La Land idea is because sometimes people are a bit dogmatic in their approach. Some people say, well, actually integrating disparate tools in your tool chain is actually a lot of work, and you have to upgrade to new versions, and you have to maintain the glue code. You're better off with one solution that does everything for you and has a consistent interface, and you don't have to worry as much. And on the other camp, there are people who say, well, if you own your tool chain, you can pick different jobs or the best tools for different jobs. And also you are being more explicit about what you want to do in your pipelines and actually getting some common agreement between different teams. So we can face off the two approaches and see what's best. If we want to visualize it in a very, obviously, very simplified way, an integrated solution has the embedded workflows and for your pipeline in the tool itself, has a consistent interface, one point of access, while a DevOps tool chain is typically has an orchestrator like Jenkins or GoCD from ThoughtWorks, and then you pick the different tools to do parts of the pipeline and you put them together. But actually, let's stop for a minute and think about this. The fact is, I've given this talk a couple of times in the last year, and the speed at which these tools are evolving, I think nowadays it makes less and less sense to be focusing what's the better tool, what's the better approach. We have to go back and think, actually, what are the practices that I want to have in my pipeline? And maybe one of the approaches works better for that, or maybe the other one is better. But we have to focus on what do we want to do in our pipeline, what are the practices we want to have, and then look at the tools. So let's scratch that and really think about practices first, and then look up the tools that can help us. That said, there are still some practices that I recommend which are difficult with an integrated solution, and we'll see why. And recently, my friend Matthew Skelton, he had this tweet where he was a bit of a rant about how GoCD has some features like role-based access, having your configuration in Git as code, what else? And quickly being able to design new pipelines and see how they will evolve with GoCD. And I agree with that to some extent, but really all the tools like Visual Studio Team Services has come a long way just in the last couple of years. So they're really converging to having all these features, the different tools. So it's getting to be less of a discussion which is better and really focusing on your own needs and practices. And I was more adamant about, well, you need to own your tool chain a couple of years ago. And today, I have changed my perspective a bit. So if we go back to the source of continuous delivery, Dave and Jazz were talking about getting changes quickly and safely into production, into your customer's hands, and then automating that through a deployment pipeline. Just to get an idea of the room here, can I have a show of hands? Anyone who has some kind of deployment pipeline in your organization? Doesn't matter what it does. Okay, keep your hands up, please. Keep it up if the whole pipeline is automated. You only have automated steps in the pipeline. Okay, and keep it up if the pipeline actually deploys to production to a live environment at the end. Okay, it's pretty cool. We have like 6, 7 people. Maybe, well, those people can leave. No, I'm just kidding. I hope you'll find interesting things. But the point is that, in my experience, there are different stages of maturity, obviously, in different organizations. So for me, what I've seen with clients is they tend to focus on the individual tools. What is the right tool? Is it the Jenkins or Visual Studio or GoCD, etc.? They tend to focus on what's familiar, what do I already use, can I just keep using the same, how much does it cost, which sometimes a bit mind-boggling because the cost of support for these tools, if you want professional support, is not comparable to the cost of your people wasting time looking up problems and not having proper help. Ease of use, sometimes they are worried about security, which it all makes sense. And sometimes they focus on scaling in the sense of, okay, I want in medium, large organizations, I got my pipeline, now I want every team to use the same pipeline and do the same thing. That kind of scaling, which makes some sense, but I don't think that should be your first concern when you're trying to adopt and improve your continuous delivery. What I miss is more focus on, okay, what actually are the practices and what do we expect to gain from those practices with our pipeline and our delivery system. And to me, at a very high level, the goal should be to have a resilient delivery system, and we'll see later what I mean by that. That also enables faster and faster feedback loops and shortening the cycle time in our pipeline, in our delivery, as a kind of high-level guiding light to the changes we might make. And the thing is, over time, if we don't put enough care in our delivery system, we start to have issues. Scaling, as more and more teams adopt our tooling, and the pipeline start to have issues with how long it takes to do things, integration with third-party, if we're using tools that don't have an API, or each tool has a different way to operate. It gets hard to evolve the pipeline. And the resilience also is affected in the sense, I call it coffee time because it's when developers say, okay, the pipeline is broken or the tooling is broken. It's not the code, it's not the test, so I'm going to go to have a coffee, a really long coffee, because this tends to take probably hours to get fixed, and have the delivery system up again. And also you see creeping in some bad coding, scripting practices in the pipeline, where you see duplicated code, you see magic numbers that no one knows why do we need that number there in that script, but no one wants to touch it so it doesn't break. And generally the code gets less and less readable and evolvable. The code that glues up and makes the pipeline orchestration. And in the worst cases, the code is only in the user interface itself. If you don't put it in a script in version control, that's the worst case scenario, which is common in the early days of Jenkins. So in the end, what happens, our delivery becomes a bottleneck, and we have our nice production environments with well taken care of, all the lights on, we have monitoring, alerting, as it should be. But then our delivery looks a bit like that, where we don't put a lot of care in our tooling and how things are working together. And then when it fails, when we move a stone, then the whole thing collapses and it takes really long to put it up again. And we can think of recent cases like a couple of years ago, British Airways, the fiasco where thousands of people were stranded and they could not go on holidays or come back home, etc. I don't know all the details, and also, obviously, making sure the data was consistent when they got their systems back up was surely a big problem, but it looks like their delivery system was also probably not in the best state if they couldn't bring up their systems quickly enough. So let's start with the pattern of picking the best tool for the job. It's nothing really new, it's common sense, but how can we actually think about this? So with an integrated tool chain where we pick different tools for different jobs, typically those single purpose tools have an API, and really nowadays that's table stakes for having a good pipeline integration to be able to use the tool's APIs to execute what we need. And why is that? Is also because then we can start using good practices like if we want to switch a tool by another because we have new requirements, we can just implement new adapters. So our pipeline code is the same. We're doing the same practices, but then because we have a new tool with a new API, then we need to write a new adapter to do the things that we need in the pipeline. That's actually from my hotel room. When you come from the EU, you have all these adapters. And that allows for starting to have repeatable mechanisms and minimize the rework in our pipeline and in our tooling orchestration. So and when you have an integrated solution, it might have good APIs, it might cover all the feature set, but typically what I've seen, but again, this is continuously evolving, but I've seen some solutions where it's kind of patchy. It's like, well, we have an API for this part, for this subset of the features, but not for that part. And in the end, the user interface is really the only reliable view of all the features that the tool offers. So that is not recommended, so try to avoid that. Make sure if we have good APIs that cover the whole feature set, we can also customize our pipeline and do more things that might be specific to our context. We'll have a look later as well. So imagine we have this obviously very simple pipeline, but if we're building Java applications and we were storing our jars with a Maven repository, for example, and now we went for Docker, so the Docker image becomes our binary that we push through the pipeline. We probably need to change the artifact management tool. Maybe we'll use Artifactory or whatever supports Docker images. So it becomes a matter of just changing the tool, writing a new adapter for that, but the practices remain the same. And that applies for the other tools in the pipeline. And eventually, in a couple of years or less, you could have a totally different set of tools that are fitting your new requirements, but the practices are still the same. So that's the point I want to make, that the flexible tool chain is standardizing our practices and not the tools. The tools can change, they can evolve, but we make sure that we know what practices we want to do and we stick to those. And tooling should evolve then when you need it because your requirements have changed. And obviously, when it's an integrated solution, that can vary as well. That can vary because you might have a new requirement, but the vendor of that tool or the creator of that tool, that new requirement you have might not be on the roadmap or it's for later. So you have less control. And the other thing which I find important is to limit the blast radius of problems in our tool chain or in our pipeline. So if we have tightly coupled tooling, and this can happen also in integrated tool chain, not just in a one solution tool. If there's a coupling between the tools themselves, then what can happen is one of them starts failing. Imagine you've upgraded to a new version of Maven, for example, and actually it's not as backwards compatible as you thought, and you have to make changes in your POM files to be able to build the Java application again. But that should not stop us from being able to use other parts of the pipeline. Imagine I have artifacts that were built previously that I want to redeploy, or I have new infrastructure in production and I want to redeploy my artifacts. I should be able to do that. I should not be stopped because the impact of that problem in the build is affecting all the features in the pipeline. And one example from a client that we're actually doing a proof of concept, and we're demonstrating like the benefit of having dynamic test environments created during the pipeline and destroyed during the pipeline to run tests. So we were using Terraform for the provisioning of the infrastructure in the cloud, and then the next step in the pipeline was to configure that new environment with all the dependencies for the application that was going to be tested, etc. And for example, Terraform has a command called Terraform output, which provides a listing of all the resources that it has created, the infrastructure details, which was needed by Ansible in the configuration. But instead of running Terraform in the two sides, in the two stages, what we did is, OK, let's run Terraform output in the first stage. We generate an infrastructure description file, which is then an artifact that we can pass through the pipeline. But we don't need to use Terraform here in the second stage. And why is that useful? It's because if later we want to replace Terraform by another tool, maybe we want to use CloudFormation because everything is on AWS, we don't have to worry what are the places where Terraform was being used. We know it's only the only place where it's used is in that stage, so that's the only place I need to change it. So that gives us, it's really applying good practices from development into how we think about the pipeline. It's kind of simple example, but we can, is the idea of thinking about this, thinking about where are we coupling and we're putting more dependencies on tools where they're not needed. So again, we want to limit the blast radius. And in that case, if one tool is no longer working for whatever reason, or imagine the file system where the tool is storing the artifacts is full, so we cannot store new artifacts, then we are not limiting the ability to do other things in the pipeline. OK, so the second pattern I want to talk about is looking at our value stream. So what are all the activities that for real need to happen for a change, for any non-trivial change to go into production? So in this pipeline, I'm sure you could point out a lot of activities that would be missing, like different kinds of testing, creating provisioning environments, etc. So this is a very simplified version. But the point is that we tend to think only about the technical bits, the stuff that we can automate, that we have tools for. But usually there's a lot more going on in a value stream. In reality, what are all the steps that need to take place to get a change in production? So this is an example from a client where they presented this as their pipeline, how changes got into production. And it looks pretty decent. There are different kinds of tests they were performing. There was an operational acceptance stage before going into production. But the first thing we did was run a value stream mapping exercise where we got people from the different teams involved and actually, with pen and paper, write down what are all the activities and the sequence of those activities to get the change into production. And this is what came up, and this actually should be one line. It's just there's not enough space in the slide. And if you zoom in, even some of these stages actually were composed of multiple activities. So it turns out, for example, the DBAs were strongly involved in any change that affected the database. They were doing manual backups, configuration, validations before actually deploying a change in production. So the point of having these things mapped in your pipeline is that these pains that you have in your delivery, that you already know about them. You know that if there's an infrastructure team that takes days to provision new resources, you know that that is a pain. But if you visualize it in the pipeline, then it becomes much more obvious where the bottlenecks are. And also you start to be able to measure that and have evidence of why is this the biggest bottleneck today for us to deliver our changes faster to production. And it turns out that those bottlenecks often refer to, offer a sign that there are silos, that there are teams working, they're trying to do their best, but they're not looking at the optimization of the pipeline. They're looking at optimizing the work that they have inside the team. So typically functional silos. And if we identify those, and we can see in the pipeline that most of the time is lost in wait time, waiting for the other team to do something or validating something. And the execution time is typically not where most of the time is wasted, unless you have, like I was asking, a fully automated pipeline to production. So, if we're looking at, for example, build time, it's 30 minutes to build my app. That's too long. I want to cut it down to half. Obviously, that's a good thing, but there might be other bottlenecks, which if you don't have in the pipeline, they are not as visible. And if it takes hours for DBA to do all the things they need to do for delivering something to production, then that's a much bigger bottleneck than your build time. But in medium and large organizations, we also cannot just go, okay, let's automate all these things, all the checks and all the provisioning, etc. Because there's a lot of baggage in the teams, and we cannot just say, okay, we're automating everything. We need to do that gradually and get people to trust each other also, and that takes time. Because breaking down silos actually is quite hard. It sounds nice. It's one of the main things about DevOps, but in large organizations, it's quite hard because there's a lot of historical baggage about how teams think about each other and why they got to that silo where they feel safe, right? They know inside my team, inside my silo, I have more control of what I need to do and how I do it. And the other thing I want to highlight is to keep in mind what are non-technical users of our pipeline. For example, let's think about Amy, who is a product owner. She needs to make decisions about releasing features into our customers, unless we're doing continuous deployment. But typically, we want to time and decide when we want to make some features available to our clients. So if she just looks at the pipeline tool, in this case it's GoCD, she might see that there are 2 pipeline runs that have passed all the stages until production. So we can initiate the deployment to production, but she doesn't know what does that mean. Which one should I pick? She cares about the features, right, that she wants to make available to customers. She doesn't care about the technical details, and she shouldn't have to dig into the technical details by herself or having to go talk to everyone, developers, testers, operations, to understand really what's the state, what does that mean, that picture there, what does that mean? So we can rely on user personas to identify this class of users, what do they need to do, what are their frustrations, the problems they have with our current pipeline and toolchain, and look for ways to make this much easier to consume. Because the information is there, the information she needs is in the pipeline, is in the tooling. It's just the access is not very easy. And this could be something as simple as an email notification where we're telling Amy, look, this feature, make money, is ready. It's in this pipeline run. But watch out, because maybe there are other changes in that pipeline which are not finished yet, for example. So you might want to wait for those or deploy a previous pipeline. But this helps to get information out to non-technical users. They are part of our delivery as well. So to sum up in this pattern, if we map the real workflow, the value stream in our pipeline, then we can start visualizing bottlenecks and work towards building the bridges between teams and removing the silos, and automate where we can gradually. And we can look out for non-technical users and what do they need from the pipeline as well. OK, recover quickly, which I think we did from the before when we went out. That was not too bad, 10 minutes. So in our delivery systems, we want to recover quickly as well, right? So that's what I mean by resilient delivery system, is a system that we can recover from problems as quickly as we can. So the old view, I'm sure you're familiar with this, but the old view of IT systems was that we want to reduce the number of failures we have. We want time between failures to be as long as possible. And the time to repair, well, we kind of tried to repair as quickly as possible, but we didn't really put a lot of thought into that, how to do that. And the new view today is that we understand systems are more and more complex with more dependencies and a lot of things that are out of our control that can fail. So we accept that there are more failures, but we want to make sure the time to repair and to get back up after failure is as short as possible. So we should apply this idea to our delivery system as well, not just let it, as if it works, just leave it and don't touch it. We need to be actively making sure it's resilient. And when we look at time to repair, it's typically at least two main components: time to diagnose the problem and time to fix. And at least in my experience, the time to diagnose is maybe 80% of the time. And then once you identify what was causing the failure, then typically it doesn't take as long to actually fix it and get it up and running again. So diagnosing is very important. We want to try to reduce the time it takes to diagnose problems in our delivery system. And for that, we need to have ownership in multiple senses. So not only owning the logs of the tools that we're using and understanding what's going on, and logging also the actions we're doing in our scripts as well. But also, there has to be some ownership of the delivery system. So if in an organization, if the pipeline is broken, like I said, and the developers say, well, it's not the code, it's not the tests, it's the tooling, or it's the infrastructure of the delivery system that is broken, I'm going to go and have a coffee. And no one else is responsible for initiating the recovery of the delivery system, then it's probably going to take a really long time to get back up. So you can have different ways. You can have shared ownership where everyone feels like if the delivery system is not working, it's my responsibility to focus on that. That's the first priority, and see how I can help. Similar to continuous integration idea that if a test fails in the pipeline, then that should be my top priority to fix the test or help get the tests running again, passing again. So here, either you have a shared ownership that everyone feels like that, or at least you have some people who are the initiators who are on alert if the delivery system is down, is failing, that they initiate the recovery and diagnosing of what's going on. So logs are very important, of course. This is an example. It's not too bad. It's kind of readable to some extent. There are, I think, a couple of problems with logs, which is either they have too much information and I can't make sense of it, or they don't have enough information and I can't make sense of it. The thing is, having too much information is kind of a solved problem, but not having enough information because the tools themselves don't log enough, or they don't do it in a structured way that I can then search for, is a problem that is harder to solve. I might ask the vendor or the creator of the tool to improve the logging. If it's open source, I might actually try to do it myself and make a pull request. But typically, that's more out of our control. Well, if we have too much information in our logs, we can use log aggregation. Sam Newman has a very straightforward definition. I'm sure you're familiar with this, but basically you forward the logs from the machines where they were generated to a central location, and then you can index them together, and you can query them together. And also you don't have to access the environment where they were originated to diagnose problems. So this is definitely something we should be doing with our delivery system as well. But there's a caveat that log aggregation and then finding correlation between events through our pipeline needs something which is an ID, a correlation ID that we can identify where is the pipeline where this happened. But fortunately, with pipelines, deployment pipelines, we typically have artifacts with, if we're using semantic versioning, that we have an artifact which has a unique identifier already. So we can use that as our correlation ID in the events, in the logs from the different tools. All the tools will be referring to that same ID of our artifact with a semantic version. So that's typically not a problem. So at one glance, we can search, okay, if I have a problem in this pipeline run, I can use that ID in my log aggregation tool and find out what happened. So it's not foolproof. It doesn't mean that you won't need to go digging sometimes a bit further, but it gives you kind of overview of what happened in that pipeline, what was the sequence of events through different tools. So if you can think about what is the information that the tools are providing, how are the logs that they provide, well, if you have access to them in the first place, because sometimes tools just rely on the user interface, and we've all seen very generic error messages like couldn't start the VM or deployment failed, but there's no more context information. So should avoid that, and the providers of those tools should be working on making logs accessible and having enough information to diagnose problems quickly. There's a little kind of mean tweet, but I like how he's talking about it. Like when someone says, oh, this is transparent for you, you don't have to worry about it, that means when it fails, you have no way to fix it because you don't have access to the actually what happened. So you can't diagnose quickly and improve if you don't have enough information. You need to be able to own your logs. So when you're selecting tools to do different jobs, look at how they log information. Is that enough to diagnose problems? Find correlated events, and then you'll be able to reduce time to diagnose and repair. So this is what we've seen today. There are a lot more practices that I recommend to clients, depending on what stage they're on. This is just meant to be a short list of other practices you might want to look about. So for resiliency of the delivery system, we start thinking about what if there's a disaster and the whole system is gone and I have nothing. To be able to recover quickly, well, we need to have the actual pipeline infrastructure defined as code so we can quickly restart it, have the pipelines themselves and the activities in the pipeline defined as code or configuration. We might think about our pipeline infrastructure as immutable infrastructure in the sense that if I want to make any change to my tool chain, to my pipeline, or the infrastructure where it runs, I should create, with immutable infrastructure, I should create a whole new environment and then just switch from one to the other and roll back if there's any problem. So kind of blue-green deployments. And obviously monitoring and alerting on issues on our pipeline, on our delivery system, just as we do with production. And finally, auto-scaling if you can to make sure that if there's a lot of high load, of builds and pipeline runs that it doesn't slow down considerably. And for faster feedback, I would consider having dynamic test environments, so not relying on static test environments where typically you end up having multiple teams that depend on that same environment, and starts to get complicated to get to actually run tests there quickly. You can think about dynamically scheduling the tests in your pipeline. So the idea is to try to fail as fast as possible. So maybe I want to run first the test that failed in the last run to see if they're still failing. Or I want to run flickering tests to see if I fixed the problem or not. Whatever makes sense, whatever feels like this is more prone to fail, so let's run those first. So I get feedback faster. Focusing on efficiency of flow, so this is related again to the value stream, and making sure we can identify what are really the largest bottlenecks and focus on that first, and parallelize wherever possible to get faster results. So I'm sorry if it was a bit fast. Really the takeaways that I would hope you get from this session is treating our delivery system as a production system as well, and being able to evolve it and design it in a way that supports evolving requirements and our practices and the tools we use. Visualizing the actual workflow, the value stream in our pipeline to help us identify silos and then work on removing those. And reducing the time to repair or the time to recover from issues in our delivery system requires ownership. So these are some sources I used for this talk. And I'm co-writing a book with Chris O'Dell, which is really about all these practices and how we can make software more reusable and improve our delivery systems. You can follow the Twitter account if you want to know about updates when the book is coming out, and there's a website as well. So I just going to end with this idea again. You might have a different goal in your organization for what you want to do with your continuous delivery initiatives, but I think I like this as a high-level goal of why are we doing things this way, and why are we worried about certain things is to achieve more resilient delivery systems that enable faster and faster feedback in our pipelines and in our build and delivery. So with that finished, thank you very much for having me.